Typically when we run into a quadratic where the coefficient in front of the squared variable isn't 1, we have to use advanced quadratic factoring. But in this case, every single term in the quadratic is divisible by 3, so we can factor out a 3 and then approach the problem as we would with normal quadratic factoring. We know that we need our first two terms to multiply to equal n squared. We know that our last two terms are going to have to multiply to give us a positive 35. And we know that our inside and outside terms are going to have to add to give us negative 12. So we're looking for two numbers that multiply to give a positive 35 and add together to give us negative 12n. Now we need to be careful to keep the 3 that we factored out before as part of our polynomial, and we're going to plug in for our first two pairs n and n because we want n squared. Now if we look at the factor pairs of 35, we're going to get 35 and 1 and 7 and 5, and the only two of those that we could add together and get 12 are 7 and 5, and they're both going to be negative to make sure that we get our positive 35 and our negative 12n. As a final step, we want to check all of our multiplication and make sure that we're ending up with the polynomial that we started with. So our n times n is going to give us n squared, which is what we're looking for. Negative 7 times negative 5 will give us positive 35, and our inside and outside terms are going to add to give us negative 5n and negative 7n, which will give us our negative 12n. So our final answer is going to be 3 times n minus 7 times n minus 5.